Good morning. Today we are going to study about the types of fibers. So fibers are generally classed as three types based on material, mode, refractive index. Based on material, we are classifying the fibers into two. One is glass fiber, plastic fiber. So in glass fiber, the core is made up of GeO2 or silicon dioxide. So it is a combination of GeO2 and SiO2, and cladding is made up of SiO2. In the case of plastic, the core is made up of polystyrene and cladding is made up of methyl methacrylate. And mode is nothing but the path or the way for the light to travel. So based on the mode, we are classifying the fibers into two. One is single mode fiber, the other one is the multi-mode fiber. If there is only one mode for the propagation, then it is called as the single mode fiber. Here the core diameter is very small, and the refractive index difference between the core and cladding is very small. So multi-mode fiber is just opposite to the single mode fiber. Here many modes of propagation is possible, that is many pathways are available for the light to transmit. Core diameter is very large and the refractive index difference is also very large. So in multi-mode fiber it is very easy to launch the light inside the multi-mode fiber. Next, refractive index. Based on the variation of refractive index, we are classifying the fibers into two. One is step index fiber, the other one is graded index fiber. So step index fiber, again we are classifying it into two: single mode step index fiber, multi-mode step index fiber. So single mode multi-mode means step index fiber is generally defined as if the variation of the refractive index of core and cladding takes place in the form of a step. Okay, it is taking place in the form of a step, then it is called as the step index fiber. If it is taking place in single mode, it is called as a single mode step index fiber. If this happens in a multi-mode, it is called as a multi-mode step index fiber. So in single mode step index fiber, it has a very thin core diameter. So generally the core diameter is of 5 micrometer to 10 micrometer, and cladding is of 50 to 125 micrometer. And numerical aperture is very small, and only one mode of light is allowed to propagate. And here the intermodal dispersion loss is minimum. So it has a very higher bandwidth. So for long distance communication and all, we are using the single mode step index fiber. Multi-mode step index fiber has a very large core diameter of 50 to 200 micrometer. Here the cladding varies from 125 to 300 micrometer. So numerical aperture is very large and many modes are available for the light to transmit. Intermodal dispersion loss is very high and it has a lower bandwidth. So graded index fiber, we are going for this fiber since in multimode fiber the intermodal dispersion loss occurs. In order to avoid the intermodal dispersion loss, we are going for the graded index fiber. Here the variation is not takes place in the form of a step. Here the core diameter is not uniform throughout the fiber. The core diameter is maximum at the core. The diameter is maximum at the core and it gradually decreases at the ends of the core. So it is not uniform. So because of this variation, what happens when you when the light is entered into the fiber, it converges. So even though it is taking different paths, at one single point it is converging, then it is traveling. So because of this, we are eradicating the intermodal dispersion loss. So intermodal dispersion losses, it's taken place in the multimode fiber. In order to eradicate the intermodal dispersion loss, we are going for the graded index fiber. So graded index fiber, the core diameter is not uniform. The refractive index of the core is not uniform. It is maximum at the core, that is the center point fiber axis, and it gradually decreases at the ends. So because of that, it is converging to a single point. Thank you.